Hey guys, apologies for the state of my hands. I've been working on the lathe basically, and no matter how much I try and wear gloves, and gloves really don't put up with oils for too long, so invariably you're gonna end up looking like you've worked on an old Chevy that has more oil leaks than oil fills. And yeah, so now for something completely different to last week, or whenever the last video was. I mentioned a friend of mine got one of these. It's a nifty little 4.5 digit, I think. Yeah, 4.5 digit voltage calibrator. It goes from 19.99999 volts to negative 19 point whatever. And it's pretty nifty. It's got an LM399 inside, and on the back it has the raw 10 volt reference on one of these pins, and some low thermal EMF connections, so you can conveniently put this into something and use it as a nice configurable voltage source and not have to plug anything in front. And there's also an adjustment for basically whatever comes after this last significant digit here. And this has already been through some modification. So this was initially a 110 volt unit on 115. And I've ordered a custom toroidal transformer for it, so we can run it here in Euroland in 240 volts. I'm going to show you inside, and I'm also going to show you the original transformer. I'm not sure whether the toroidal one was a good or bad idea, but it seems to be working fine with no performance penalty or anything else like that. It fits, which was a main concern because the original transformer is pretty small. And what am I going to do today? Well, this digit, as you can see, has a problem with the ratcheting pawl that's inside that clicks it basically upwards. So in this lower third, I think there's some wear in the mechanism and the plastics inside, and you can't really set what you want here nicely. And for somebody who has a certain degree of obsessive compulsive disorder, having them all set with one at just a slightly different angle is pretty infuriating. So I have managed to find a pair, if I can find where I put them. I've managed to find a pair of original Cherry switches. Yeah, these are made by Cherry, the makers of fine keyboard switches since yore. And I'm planning on taking this apart, sticking this in instead of this one, and sending it on its way to its rightful owner. By the way, this isn't the digit that was originally broken. The one that was dead was actually the second one here. So the second most significant digit. Obviously, for obvious reasons, I think this is the one that you'd adjust the most in regular use. And yeah, I just moved it to the last position basically. So I got some more functionality out of it, or more pleasant functionality out of it, while I was waiting for these to arrive. So this is quite a pain to take apart, and to a certain extent it's not very neither convenient nor intuitive to disassemble. So there's these 4 screws on the back, and apparently a mosquito, which I managed to assassinate. Yeah, it's getting into summer here, so mosquitoes appearing, which is very, very bad news because I hate mosquitoes, like the majority of humanity, I think. And when I was a kid, I used to be severely allergic to the point of delirious fever from mosquito bites and stuff like that. Absolutely horrendous insects. I just assassinated another one. Apologies, that's a bit gross. You tend to, you know, get a bloodthirst for mosquitoes when you've spent as much time dealing with them as I have. Okay, now after these 4 screws, there's 4 hidden-ish, where are they? Socket heads, they're not socket heads, they're grub screws, and they're Allen, and I think they're Imperial. So I have this nifty little Imperial set of Allen keys from Engineer. This is made in Japan, and they're pretty darn nice. So this is a 1/16 inch, I think it's the 1/16. No, it's a 1.27 millimeter. I have no idea. Half of them, or a number of them, are in Imperial, and a number of them are in metric. So 1.27 should be 50 thousandths, I think. Because 100 thousandths is 2.454 millimeter. Yeah, it's 50 thousandths of an inch. It's half the regular spacing of, you know, those pin headers and these. So 0.1 inch, this is 0.05. Okay, so once we've done this, we can access these screws, which also need to be removed. They hold the 2 halves together in a differenter way. And then we can take off half of the clamshell, so the top half of the clamshell, which reveals the inside. So let me try and bring you in for a closer look. Nice. Okay, so we have the toroidal transformer that I replaced the original one with, and the cherry switches, and these are basically a voltage divider basically that sets a feedback for the reference circuit in here, and this allows you to set the, you know, the output voltage. The schematic for this thing is pretty, first of all, the official schematic for it is non-existent, and somebody on the eBay blog did some work and tried to reverse engineer it, but found it very, very hard to follow, and you know. So and you can see that this is a 1248 configuration switch, so you make all the 0 to 9 using combinations of 1248, and there's resistors in succession of 1248 in here as well for every switch. So I'm not gonna bother, I'm not gonna, you know, bore you with taking all of this apart. I'm gonna pause the video and I'm gonna resume once I've got this section here separated. Okay, I'll be right back. One thing I forgot to mention is that in order to take the front panel off, you actually need to unsolder basically almost everything. So including the connections to the binding posts or the banana jacks on the front, which is easier said than done, especially when you got a camera in between you and the thing that you're working on. And of course, in typical 70s or 80s fashion, this thing is full of tantalum caps. And yeah, so this is about what it looks like right now. You can see that the bezel is free, so the front panel is free. And the thing that we need to do now is, first of all, let's not lose any of the hardware. I'm going to flip this upside down, and I'm going to unsolder this row of connections, these that you can already see that have been touched previously. So these connections are basically this board that piggybacks the switches. So I'm not usually a huge fan of desoldering tools. I prefer, we have one of those air-powered Metcals at work, but this little devil here, made also by engineer, is just insanely good. So I've never had it leave any solder in a hole, no matter how plugged it was, after a few tries. It's by far the best desoldering squeeze-em-a, suck-em-a thingy I've ever had, and the fit and finish of it is just spectacular. It's like rubber O-rings everywhere. The inside is nice and precision machined and smooth, and the silicone tips are just wonderful. It's a brilliant, brilliant idea. One thing that you need to be cognizant of is that if you're trying to suck a lot of solder, so like one of these patches here, it doesn't really cope well with that. So it will clog because the fit between the little plunger inside and the bore is so tight, and you know, any excess solder more than a regular through hole is just gonna block that from exiting, so you won't be able to reset it. It's simple enough to just stick something in there and clean it. And you should also kind of use a specific grease that can be a very, very, very light grease on the inside to keep it nice and smooth. And it also needs to, you know, be compatible with silicone O-rings, because you know, that's how you keep it performing at its peak, and how you keep it running, and how you don't destroy silicone O-rings. So the wrong grease on these things will destroy the O-rings inside in short order. So don't use WD-40 on this thing. Okay, I'll be right back. Okay, so this thing is free now, and the way you undo it from this board is, just let me bring you in a bit closer still, is you have to remove all that solder. So you can either do this with a wick, but you risk just ripping off the pads, or you can do it with the solder sucker thingy. I'm gonna do that, and then I'm gonna show you what the mechanics of this looks like, because there are some mechanics that you need to take apart before, you know, finishing this up. Okay, so I've removed this one, and you can see I've attempted in the past to fix it. There's some hot staked pins that immediately give up the ghost when you remove these, so they're basically unrepairable. And why this happened, why this broke, is because there's a, I hope I removed the bad one, yeah. There's a sort of a ratcheting mechanism inside, and this wheel wears. And this is basically what makes the ratchet. It's not really a ratchet because it doesn't make it move in just one direction, but you get the point. It's like a ratchet. It's more or less like one of those ratcheting drivers, keys, what do you call them? You know, the things that you use for working on cars, but it works in exactly both ways. So instead of the pawl being offset to one side and allowing motion in either direction, this is basically just there as a detent, nothing more than that. So let's compare this to what we have on this one. So looks a bit more complex. I hope this is correct, and it's not. Crap. It's the wrong switch. Maybe it can still be salvaged. Hopefully. Maybe. Let me think about it. Alrighty. Apologies for not filming that, but I was really worried I might break it completely. So what I ended up doing was breaking off these hot staked pins and swapping basically the guts that didn't work from one to the other. Now it's nice and positive and it works. And I gotta insert it back into here. And it's different now, it's shiny, and the others aren't, which sucks. And now we need to put the bezels back on, which go like this. We need to line up the holes in them, which is easier said than done. Make sure to first line up the holes and then solder the things. Luckily I didn't do that or neglect to. I didn't neglect to line it up first before soldering, but that would have been absolutely tragic were I to have forgotten that. And the other bezel is already here, and I just need to dig for the other one of these spring clips that I'm sure has to be somewhere around here. Oh yeah, found it. Okay, so technical difficulties. While I was looking for the spring clip, actually when I was trying to extract the spring clip from the shaft itself, I managed to slice one of my fingers open pretty bad. You can't really see it, it closed up pretty quickly. But now, what we need to do is fill in those pads with solder. And I'm gonna try and show you that. Maybe if I zoom in all the way, you should be able to see. It's not great, but it's not terrible. So try not to stick the hot soldering iron for too long on the precision resistors. So something like that. Make sure it ties in and makes a nice fillet. I'm looking through the phone. I should be looking at what I'm actually doing. And okay, let me bring you in for a closer look on in a different way. Okay, so this might be a bit more jiggly than the previous setup, but I think you should be able to see a bit better like this. So there's one more terminal that I need to deal with in here. Oh, sorry, bumped the camera already. I'm not entirely sure if this is going to work, but that's the general idea of what you need to do. And I think this side might turn out to be a bit easier, considering the fact that I can also see unimpeded. All right, so the iPhone is a pretty bad soldering microscope, let's put it that way. And the final one, which is kind of hidden around here like that. What you want to do is basically not do what I'm doing, and I kind of touched the last resistor a bit, you can see it, but those look respectable. I guess a bit less solder than from factory, but they're nice and shiny. This is not lead-free solder. I don't know. Okay, now we need to stick this back in the assembly, and we're gonna give it a go, see if it still works. By the way, the vias on this thing aren't through plated, so I'm not entirely sure. You know, you might lose a pad or two on the bottom, especially. I think I lost a lot of pads in the 2 cycles of assembly and disassembly of this thing. I tried soldering these from the top because that's where the connections actually are, and I managed to do that one pretty good. I'm gonna return for the one that I missed, but I need a different angle of attack. I don't know if at all if you can see what I'm doing here. Pretty much nothing, right? Okay, then I'll just solder these and bring you back with it working. Alright, so I don't know if you can see that, but it's set to 10 volts and it's pretty bang on 10 volts. The LM399 warms up pretty quickly. And I don't know what digit I changed, 10.1, yeah, sure. And yep. It's still a little bit stiff after disassembly and reassembly, but I think you'll find that the last digit, 6, 5, 4, 3, 2, 1, not. Yep, repair works successfully. Oh, if you want to configure yours for 220 volts operation, as in if you want to get one of these and you can only find one in the States and want to import one, let me find the original transformer and show you the... So the original transformer looks like this. Pins 1 and 2 are the mains, and the other two windings are a 32 volt AC and a 42 volt AC winding. I ordered this is a 7.6 VA, so about a 5-6 watt core. It seems plenty. The windings are specified to be 100 milliamps each output. I'm not sure this is enough to meet the full output specification of this thing, which is about 60 milliamps. But again, who's gonna pull 60 milliamps out of this thing? You know. Anyway, I'm gonna put it back together, but I'm not gonna make you watch the reverse of the dismantling operation. Everything works as expected. So positive, negative, 0, 1, 10 volts basically, 9 volts, 0.9 volts, 90 millivolts ish, because we're already, you know, it's not very linear towards the low end, and 10 millivolts. It's good enough. Okay, see you next time. Bye.